my pleasure. Okay, it is my pleasure to present our topic on behalf of my colleague, Professor Dr. Vladimira Angelova. And myself, Aleksandra Nikolova. We are from Plovdiv University in Bulgaria. You already heard the name of our topic, so I will tell you more about our study. Our experimental study was conducted with 250 students for 3 consecutive years from 2022 to 2025. At the beginning, our students were 8 years old, and at the end of the experiment, they were 10 years old. It is our 2nd to 4th grade in our primary school system. Nowadays, when students are trying to find unknown number in equations, they're intuitively guessing the number and after the fact checking if it works. But this method is unreliable, more so when the students are 3rd or 4th graders, when they use multi-digit numbers and it is hard to guess the number. So in our innovative method, we use rules for finding the unknown numbers. We want our students to use a relationship between arithmetic operations and not to rely on rote memorization. In order to move from intuitive to mathematical logic, our innovative teaching model shifts the focus from isolated equations to rational deduction. Instead of guessing and checking if the number works, we are relying on visual contextual triggers, as you will see later in our presentation. And we are trying to integrate word problems, which could give the mathematical models real world context. Because we don't want only our students to learn how to add, subtract, multiply, and so on. We want for them to learn how to apply this knowledge in the real world when they're small, when they're primary school students, but as well when they're older, when they're working adults, and so on. For our the material that students are learning in Bulgaria, according to the Bulgaria mathematics curricula, in 2nd grade, our students are learning how to find unknown addends and multipliers. In the 3rd grade, the second year of our experiment, they are learning how to find unknown minuends and dividends. And at the end of the primary school, in grade 4, they are learning how to find unknown subtrahends and divisors. What's interesting about our innovative method, we are when the students are 2nd grade, we are relying on visual models. You will see some illustrations later on, and so we want students to find relationships between the arithmetic operations, between addition and subtraction, and between multiplication and division. This is for the 2nd graders. In the 2nd year of our experiment, when the students are 9 years old and they're 3rd grade, we want them to use inverse operations to check the division with subtraction and, with multiplication, and the other two as well. Okay. In the last year of primary school, we are relying on dual approaches because the students are using multi-digit numbers, and we want to give them a choice between something that they already know and is easy for them, and the rule that will be new, and for some of the students probably would be harder to implement it at the moment. In our model, every next year, we are relying on the rules that students mastered the previous one. So it's relying on something that the students know. This will make things easier for them every next year. Now I will try to briefly showcase the model that we created. We are in second grade when students are 8 years old. As I said earlier, our students in second grade, we want them to rely on visual triggers. So we are providing a lot of illustrations. Here you can see a simplified version of the illustration. On the illustration that you can see in our report, you will see two students, a boy and a girl, holding this trays with donuts, surrounded by their classmates. So they're bringing some treats to their classmates. And our second graders have to make three word problems. In the first one, they will combine the number of blue and pink donuts to find the total number of donuts, which you can see at the first equation. And after that, they, using the total number of donuts and the number of pink ones, they will find the number of blue ones. And after that, knowing the total number and the number of blue ones, they will find the number of the pink ones. Using this logic and this connection between addition and subtraction and these visual triggers that we are providing for them, our second graders will be led to the rule that they will use when finding unknown addend, and it is the unknown addend is found by subtracting the known addend from the sum. I want to make something clear. In Bulgaria, we use the same word for the two numbers that we are adding. So both are called addend. It's the same for multiplication. In English, there are two different words, but in Bulgarian, some decades ago, the things changed and the words are the same. If it is confusing for someone whose first language is English. After that, we are learning in second grade how to find unknown multiplier. The approach is the same. Unfortunately, you can't see the illustration that we provided for our students, but if somebody is interested, you can see it in our report. We are providing the students illustration of 4 vases. In each one there is 3 daffodils. And the idea is the same with the addend. They have to prepare 3 word problems to find the total number of daffodils, the number of vases, and the number of daffodils in one vase. And again, using the 3 equations, the connection between them, using the illustration, they're led to the rule. The known multiplier is found by dividing the product by the known multiplier. We are moving on to the third grade when we want students to check the result of one operation using the other. The two that are connected. We will begin with finding unknown minuends. Our students are going to solve problems with subtracting, and after that we will use the knowledge that they already have from first grade, how to check the results of subtracting using addition. And using that connection, we will implement the new rule to find the unknown minuend, which is the unknown minuend is found by adding the difference and the subtract. The same logic is used for the other unknown number in third grade, the unknown dividend. Again, the students will be provided a lot of equation in division and multiplication, and checking the result of division with multiplication, something that they have learned in the second grade, and are implementing a whole and a year and some months. So this is something that they have mastered, and it wouldn't be a problem to implement it in the new situation using this combination of the two operations. So we will share with the students the new rule, which is the unknown dividend is found by multiplying the quotient and the divisor. And now we are moving on fourth grade. When I present you the curricula in Bulgaria, I told you that we are providing the students in fourth grade with choice between two approaches. As I said, the numbers with which we work in fourth grade, they're multi-digit, so everything between 1,000 and a million and above million. So it will be hard for students to use the guess and check approach. So we are providing them with two choices. The first one is something that they already know and are using. We want to simplify the new equation with the unknown addend, with the unknown subtrahend. We want to convert it to equation with unknown addend, something that they knew how to do in second grade. So we are going 2 years back to something that if the students can do, we have a lot more problems than the new rule that we want to present to the students. So this is the first approach, and the second approach is implementing the new rule, which is subtracting the difference from the minuend. My experience as a primary school teacher before I became university teacher showed that from my last class, 23 of my students chose the new rule, and only one student chose the approach using the knowledge from 2 years ago. I asked her, it was a girl, why did she chose this approach, and so she said, because I know it. I'm using it, and the rules, the approach that students will use, it goes back 2 and 3 years before. So she was sure in her knowledge and not in the rule that we introduced 5 minutes ago, which is logical. But more of the students decided on the rule because it is shorter. It's one row shorter to write it, and students want to spend less time on each problem. In our report, you can see the whole problem solved. So it is 4 rows for the first approach and 3 for the second approach. The difference is not big, but a week later, she moved to the new rule. So it was a short amount of time. And last one in the second grade, it is the unknown divisor. Again, we are providing 2 approaches to reduce the new equation to an unknown one with unknown multiplier. Again, we are going back to second grade, and the new approach is using directly the rule. So the rule will be finding the unknown divisor, but by dividing the dividend by quotient. Okay. Something that we weren't able to insert in our presentation because it is a big part of our model. It is the problems that we are giving after the rule. After every rule, we are providing the students with systems of problems, moving on from the basic equations, like the one you see here, to something more problematic, needing more skills to implement the new rule in these types of programs. So it is a whole system of mathematical problems. Okay, moving on to the results of our study, it was 3 years long, as I said at the beginning, from 2022 to 2025. In our report, we shared only the results at the end of the experiment, but we make sure to find the results in the end of each year. So if the students have some problems, to make sure that we are clearing them before inserting the new rules for finding unknown numbers. We've worked with 250 students, as I said earlier. 151 were in the control group and 25 and 125 in the experimental group. The idea for this prolonged study was to capture the sustainability, which is a big part of our study, and the accumulation of mathematical competences over the time. We worked on 3 tiers when we were assessing the students at the end of each year, but now I will talk about only the end of our experiment. The first tier was the knowledge of the rule, so the basic knowledge. The second one was composing equations from text when it comes to unknown numbers. And the third, the highest level, was solving modeled word problems. So word problems when which students have to solve by equation with unknown number. This was the mastery of unknown numbers. The results, as you can see, for the first tier, the knowing of the numbers, the experimental group shows 93.6%. So almost every student of the experimental group knows the rules. But the control group, as you can see, only 75% of the students know the rules. This is an important information, but this is only the base for the solving the problems. You may know the rule, but we are not sure if you can implement it when solving the problem. So at the second and third tier of our the tests that we provided to the students, we are checking that. The second tier, when the students had to make equations from mathematical texts, as you can see the results, 87% for the experimental group, nearly 70% for the control group, and the biggest gap between the students from the two groups was at the third level. As you can see, a little over 50% of the control group can have mastered the highest level when it comes to unknown numbers. As you can see, for the experimental group, it is 75%, which is great result at the end of the experiment. As I said earlier, it was crucial for us to see if our model is sustainable, if the students from the experimental group keep their level throughout the 3 years of our experiment. In conclusion, our idea was to see if when implementing our model in the work of students from 8 to 10 years old, that we will see that using the rule-based deduction will build logic reasoning and permanently elevate the confidence in students and their mathematical abilities. We will like as well, this is the last thing that I want to share with you, to acknowledge that this study was financed by European Union Next Generation EU throughout the National Recovery and Resilience Plan of Republic of Bulgaria. Thank you very much.